Hello, welcome back. Today we want to talk about percentiles, what they mean and what they tell us. So our goals, it says be able to calculate percentiles of a data set. We'll show how to do that, and also be able to use percentiles to make comparisons. We'll understand how that's accomplished. Let's take a look. So percentiles, the percentiles are measures of location denoted P1, P2, P99 through P99, which divide a set of data into 100 groups with about 1% of values representing each group. Okay, now let's read a bit further to kind of explain what that means. Or I can kind of explain, then we'll get to that. So for the data value at the 50th percentile, right in the middle, these are positions of backups. Actually, percentiles, it says, are measures of location. So this is in line with the way the median is found. So remember, to find the median of a data set, you put the data values in order, and you find the middle number. So we don't really care so much what the middle number is. We just know that it's the middle. It's somewhere here. So what we're doing then is just putting our data sets, data values in order, then picking out, basically dividing them essentially into 100 groups where you have basically about 1% of values in each group. And those are what are called the percentiles. So for the data value at the 50th percentile, written as P50 right in the middle, this is the same as the median. Approximately 50% of the data is below P50, and about 50% of the data is above P50. So basically P50 is also the same as our median. Okay. For example, for the data value at the 99th percentile, written as P99, in the same way, approximately 99% of the data is below that value. About 1% of the data is above that value. Okay. In the same way, if you do like P25, in the same way, about 25% of the data is below P25, and about 75% of the data is above P25. Now, how are percentiles used? You're probably most familiar with them if you've taken ACT or SAT. So they're often used to kind of give an idea of comparison for standardized tests. Okay. Those percentiles are often used in standardized tests such as the SAT and the ACT. For example, a composite score of 30 on the ACT is in the 93rd percentile, or P93. So in the same way, meaning that a person who scores 30 or better a person who scores 30 or better in the ACT is scored approximately, so what that means is that approximately 93% of the people who took the ACT have scored worse than that. So in other words, if you score the 93rd percentile, you've scored better than approximately 93% of people who take an exam. Better, the same as that number of people. And then what that means also, about 7% of the people have scored better than you did. So that's about the 30th. And once again, this is the source for that data. Now, if you scored, let's say you scored 20 on the ACT, let's say that was 1%, let's say that would be perhaps the 70th percentile. That would mean that you scored better or as well as 70% of the people who took the test, and less than 30% of the people who took the test. And that's often a good idea when you have large values, especially these kind of standardized tests, where many thousands of millions of people take them. It's kind of a good way to kind of organize them and make comparisons between different data, see how well you did compared to others. Now, let's talk about actually how to find in the percentiles. It's a fairly straightforward formula. So it says to calculate the percentile that corresponds to a data value X, you find it's a fraction. The number of data values that are less than that value divided by the total number of values, which will give you a fraction or a decimal, then multiply by 100, then to give you essentially a percentile. Then we round percentiles the nearest whole number. Okay. Let's come over here to the right then and take a look at some examples. So here's our data set. Let's say this is 7 grades. And here we have our 20 values. 20 grades, also they're already in order, okay, from lowest to highest. So let's look at a few examples. All right, so find the percentiles for number 1 for 70. Okay, you want to find the percentile for a grade of 70. Okay, so what that means, the percentile then of 70, okay, is equal to, so we find 70 and find the number of data values below 70. So here I have a couple that are 70. So find the number that are below that. So if we add these up, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 values below the score of 70. Okay. Then the total is 20. Then times 100. So of course, 10 divided by 20 is 0.5 times 100, and that's 50 And so once again, what this tells us then, so 70, the grade 70 is the 50th percentile. Or we write that as P50. Okay, that's the 50th percentile. So if you scored 70 on this test, that means that basically half the people scored worse than you, and half the people scored better than you. Now, number two. Say this time I want to look at the grade of 54. Now, also the grade that we have doesn't necessarily have to be on the exam. I could pick, for example, if we had a 71, which is not on here, but still would do the same thing. So it'd be the number of grades less than 71. Okay. Now, so once again, we want to find a little arrow there. There's the percentile or of 54. So the same thing. That's going to equal. So once again, we need to find 54 and find the number of data values that are less than that. Right. So we have two data values that are less than 54. So 2 divided by the total number of data values, which is 20, times 100. And so 2 divided by 20 is 10% or 0.1 times 100. And this is 10. Okay. And once again, that tells us so 54 is the 10th percentile. Or we call that P10. Okay, let's do one more. Let's do 81. So 81 is right here. I want to find the percentile of 81. Let's look. So 81 is right here. Find the number of data values less than that. So we count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16. So 16 values less than 81. And out of total, which is 20, then times 100. And if we do 16 divided by 20, should be 80%. Also 0.8 times 100, which is 80. Once again, in this case, having any, we had to round off, but still round off to the nearest whole number if you need. Okay. So once again, what this tells us then is that 81 is the 80th percentile. Or we also call it P of 80. So 80% of the values, 80% of the people who took this exam scored less than 81. And then approximately 20% scored better. Okay. Now, for small data sets like this, some of those percentages, like say the percentage scored better or worse, it's not as easy to interpret as them because obviously we don't have exactly 80% or 20% scored better, but it gives you an idea. Okay. And this, at the same time, if you have really large data sets, like the number of people taking the SAT or ACT, then basically you can kind of make that claim more precisely. Okay. So what we learned so far then is how to find the percentiles, which is a fairly straightforward formula. Then also how they use them for comparison tools and what they mean, how they're often used, which are often in standardized tests or exams like the SAT and ACT. Thank you. Have a good day.